Okay, section 6.3, we're looking at using sec, cosec and cot. And there are two ways that we can use those. One is dealing with the identities and one is dealing with equations. And I'm going to start with the equations first, so I suppose example 8 is where we're looking. Now if you think back to the year 12 book, the first year blue book, if you looked at my advice on that, I've said you need to make the equations look like this. Sine of x equals something. Now that might be obviously a sine or a cos or a tan, doesn't have to be a sine, and that x might be something like 3x plus 60 degrees, okay? So, and the k obviously can be it doesn't have to be a nice constant, it could be a nasty thing, okay? So basically we need sine or cos or tan of something equals something. That's the form that we need. Now once we've got to that, we can use the techniques from last year. Okay, now that's still the case, nothing at all has changed about that. So if we have this, sec theta equals minus 2.5, is that sine or cos or tan equals a constant? No, it isn't. What it is though is 1 over cos theta equals minus 2.5. So in other words, cos theta equals minus 1 over 2.5, and we can solve from there. And just one extra stage. That's 1 over 2.5 or 1 over 5 over 2, so 2/5. So cos theta equals minus 0.4. Okay? Now from there, I'm not going to carry on. That is now an equation that we can solve. Of course, to solve it, you need an interval, and you need to know whether you're in degrees and radians. Now, in example 8, page 151, they say solve this in the interval 0 to 360, and we're working in degrees. Okay? But once we've got to there, we use the solving equations versions of the formula. The next example, they give us something like this, cot 2 theta equals 0.6. Well, that is 1 over tan 2 theta equals 0.6. So tan 2 theta equals 1 over 0.6. Now, that again is the sort of thing that we could do in the first year book. Okay, so if you're not sure how to solve that, go back to the first year. The usual advice though, if you've got more than one trig identity, sine or cos or tan, if you've got more than one of those, then break it down so that you've just got one of those. Use the identity so you've just got one of those. Now in this case, we've got sine, cos, tan, sec, cosec, cot. So reduce it so that you've either got either sine or cos or tan or sec or cosec or cot. Then solve the equation to the point that you get sec equals a number, cot equals a number, cosec equals a number, sine equals a number, cos equals a number, or tan equals a number. And then if you happen to have sec or sec or cot or cosec, you just use this trick to turn it into sine or cos or tan, okay? So it's the same technique as last year. And if you're not sure how to solve equations from there, go back and there's a video on it. I think it's chapter 10 from the first year blue book. Okay, and there's a playlist on this channel that runs through the whole of the first year blue book. So the next thing then is how do we deal with the identities, and again the advice is the same, but now we've got a little bit more that we can do. So I'll do one example and just remind you of the way of thinking. So this is the identity that we're trying to prove, and the old way of thinking is still exactly the same, but before all we had was the algebra that we already know. And we had two identities. We had sine squared plus cos squared equals 1, or is identity equal to 1. And we had tan theta is sine theta over cos theta, identically equal again, okay? Now, those are still true. We can still deal with all the usual algebra that we've got, but now we also have that cot is 1 over tan, so cot is cos over sine. Cosec is 1 over sine, sec is 1 over cos, cosec is 1 over cos. So we've got extra things that we can use. The advice from before still holds. Start with the most complicated looking side, try to simplify it until you get the thing on the other side. The other bit of advice that is really useful advice here is before you start, look at everything that you could possibly do, okay? So looking at this, what can we do? Well, I've got sec and cosec here, so if I had 1 over sine and 1 over cos, 1 over cos and 1 over sine, I could change those into those things. Cot I can think of as sine over cos over sine, or I could think of it as 1 over tan. Cosec I can think of 1 over sine. And I'm thinking that, well, maybe that would be the way forward, is that I could split all of these up, by turning them into 1 over something else's. Can I do anything with the fraction? I don't think so. I don't think there's anything clever I can do with the fraction here. There's no factorising that I can do particularly. So algebraically, there doesn't seem to be much to do. I've just got to use my trig identities. The only trig identities that I can do is the 1 over ones, okay? So I'm going to take the top, and I'm going to write that a cos theta over sine theta. And I'm going to go for the cosec as well, because that would give me 1 over sine theta. So the numerator here is going to end up as cos theta over sine squared. If I've got a fraction on the top, I like to put a nice big line in the middle so that I can see the numerator and the denominator separately. Now what shall I do? Shall I go for the denominator? I think I will do. I think I'll go for 1 over cos squared plus 1 over sine squared. Okay. Now looking at this, I've got not much that I can do with the top, but I can maybe do something with the bottom by adding these algebraic fractions. So I'm going to leave the top as it is, cos theta over sine squared theta, and I'm going to turn the bottom into sine squared plus cos squared over cos squared theta sine squared theta. So I've just made a common denominator of cos squared sine squared. I've got to times this fraction by sine squared on the top and the bottom, so 1 lot of sine squared on the top. I've got to times this fraction by cos squared on the top and the bottom, so 1 lot of cos squared on the top. And then I've got a fraction divided by a fraction, so cos theta over sine theta. And I can have cos squared theta sine squared theta. Sorry, there we go. Well, I have cos squared over sine squared is this one. Flip the second fraction upside down and times. And I get this. Sine squareds cancel out. Sine squared plus cos squared we know is equal to 1, so that's like divided by 1, and that leaves me with cos cubed of theta. Okay, so we're just doing exactly the same techniques as before, only we've got some extra things, sec, cosec and cot flying around. Since I've done half of example 7, let's just finish it off. Cos cubed theta equals 8 would mean that cos theta equals 2 if I cube root both sides. Why does that have no solutions? Well, because the biggest that cos theta can be is plus 1. The biggest it can be is plus 1, and 2 is bigger than 1. There we go, 2 is bigger than 1. Words of wisdom there. Right then, that's the end of section 6.3.